Okay, hello again. And here we have in Chapter 6, Section 2, we're going to take a look at example 6-7. And if I can just find the page, then I'll go ahead and pull it up for us. Here we are. So a quick view of it, I'll read it quickly. So each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed and the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating. So we have two parts. Part A, between 27 and 31 pounds per month. And then in part B, more than 30.2 pounds per month. Okay, all right, so let's set that aside. The first thing to do is, well, I've already set it up kind of here. So you can see that I've left a little space for identifying the important information in the equation or in the problem, I should say. Okay, so said the average is 28 pounds per month. So I'll just say 28. We could say pounds. We could say pounds per month, and so on. Here, the standard deviation, they said, assume that we know it, and it's 2. Okay. And then the x is the last thing that we need to find. So for part A, there's actually 2 x values. So we have mu is 28, sigma is 2. X, we're looking between, what did it say? Find the problem again. Between 27 and 31 pounds. So we're going to use these endpoints, 27 and 31, for 2 different x values. So let's go ahead and solve this problem. The first step that I'll do is sketch the distribution. So here it's not 100% necessary to do this. We don't have to sketch the distribution twice, but I will, because I'll just sketch one copy of the distribution for the newspaper waste, and then I'll sketch what's going on in the standard normal distribution. Okay, so here we have 28 is the average value, and we're looking between 27 pounds and 31 pounds. So I'll just approximately draw it like that. So notice here, we're looking for an in-between area, middle area. So when we transform this into a problem that we can handle using our z-table, we'll have z-scores to go ahead and plug in to our standard normal distribution. So the first thing that we're going to have to do then is go ahead and compute the z-scores for each of these. We'll say z subscript 1, just to indicate that that's going to be the first z value. I'll just kind of jot it down right there. 27 is not the z value, but we're going to get the z value for 27. 27 minus 28 all divided by 2. Oh, I'm sorry, what was that? I have no idea. Remember, we have to write down z equals x minus mu all divided by sigma every single time we are using that formula. I forgot this time. I'm sorry. So that becomes -1 divided by 2. So that is -0.5. So when we have our z distribution, that normal distribution has 0 in the middle. Instead of 28, we have 0. Okay? Doesn't have to be perfect, so calm down. All right, I'll be okay. All right, and so when our x value is 27, our z value is going to be negative 0.5. All right, so that's that part of it. And then the z subscript 2, that's going to be over here. So I'll just say z2 is not 31. It's the z value that we get when we use x equals 31. And then divide by 2, because we're using, I'm pointing to it on the other page, x minus mu divided by sigma. Okay, doing the same sort of thing. So that's positive 3 divided by 2 is positive 1.5. So here we have 1.5, like such. So basically, these two pictures are supposed to be identical, except for the only difference is the labeling on them. So basically, all we've done is change the scale of our normal distribution until it matches up with the standard normal distribution. And so now we're just basically answering an area question using the standard normal distribution. We're going to find this middle area. We're going to find P of 1.5. I'm not going to bother showing you this, right? Am I? Am I going to bother showing you this? Well, let's see, 1.5, 0. So, no, I'm not going to bother showing you that. Our first probability is 0.9. What did I not show you? 9332. Okay? And then this left area, the area that's actually unshaded, that we're chopping off from this part to get the middle area. So we have this entire left area minus this little portion of left area, and that gives us the middle region there. So that one will plug in negative 0.5. All right, so where is that? That's on the opposite side. Shouldn't have to show you again, but there it is right there. So what does that say? 0.3085. 0.3085. So to find the middle area, we're going to subtract this large left area minus this smaller left area, and that's all we're going to do that. So let's wake up the old calculator. We'll go 0.9332 minus 0.3085, and that gives us 0.6247. So to summarize, that is the probability of it generating between 27 and 31 pounds in a month. Okay, and I'll just express the final answer as P equals 0.6247. You could say 62.47%. That would be fine. That would be perfectly adequate. All right, so let's move on to part B. All right, so this one, just bring the book back, said, what's the probability we're going to be generating more than 30.2 pounds per month? So more than 30.2 pounds per month. All right, quickly identifying key values. Mu is still 28, sigma still 2, and now the x is 30.2. So we're looking for the probability, I'll write it like this, the probability that our x is greater than 30.2. So basically, that's the question that we're looking at with our distribution. Okay, so there's 28, there's 30.2, and notice this is a greater than, so this is a right area. Okay, so that is what we were trying to find. And when it comes to actually using the table, we don't have a table for this distribution. We don't know this particular distribution. This is just based off of data, we'd have to regenerate our entire distribution function, and the math would go haywire. So we already have well established, we have a table of all of the values for the standard normal distribution, standard, right? So when we convert it, we're basically looking at the same picture. The area underneath the curve is the exact same thing. This question mark, those are the same value, except we're just using 0, and this is going to be the z value that's attached to 30.2. Right, so that's all we're going to be doing here. We have z is equal to x minus mu all over sigma. Of course, recite it from memory, and you'll never lose it after that. So we have 30.2 plugged in place of x, minus 28 in place of mu, all divided by 2 in place of sigma. And let's see, 2.2 divided by 2 is 1.1. Okay. Don't believe me? Ask a calculator. All right. Then what? Oh, then we're going to plug in 1.1 and find the left area, and then subtract the left area away from 1 to give us the right area. Or remember, we can do the sneaky way and just look up directly. Look up a right area by plugging in the opposite z value. So that one would be 1357. I'm saying 1357. So that means that this area is 0.1357. So the final answer we'll say is probability equals 0.1357. 13.75, sorry, I said that wrong, 13.57% of the values we would expect to be in this range here. All right, so that is it for this example. Went a little long on this one. All right, bye.